First, I owe thanks to many people in the audience, Bob from Sonam, Bill from LA Ricks, and others who I may not recognize. Because of you, we've been able to take our equipment in the field and test it and learn. So thank you for all of you for making this possible. We're very grateful. And echoing the very important messages that Ken read at the beginning, we invite you to visit our booth at 1572, that's 1572 out in the field, where we'll show you some of the technology that we're talking about today. As background to my comments today, let me go through some of the exercises that we've done, which have contributed to the technology that we've been developing. First, in the top left, you can see some information about GIFX, which is the annual defense and public safety event that happens in California. In the center, you can see the cause information about the Cause 3 exercise. That was a cross-border exercise between the U.S. and Canada, organized by Texas A&M. At the top right, we were very fortunate. Houston-Harris County, as they mentioned in one of their presentations earlier, does not have in-building coverage or substantial in-building coverage, especially downtown. And we were fortunate they asked us if we could provide Band 14 coverage at one of the FirstNet board meetings that happened last year. Let's see, in the center is what we refer to as MacBase. MacBase is a three rural towns in southern New Hampshire, where you put up a network that has all possible elements of backhaul, from the worst, DSL. We're using DSL for backhaul, one of those. Don't try it, it's a bad idea. We have fiber, we have regular Ethernet, we have one node that uses AT&T LTE for backhaul, and we also have one mesh backhaul. So each, as I said, each one of these an important learning experience. The center right one was an exercise again that Texas A&M helped put together, where we were testing remote access into the Houston-Harris County core using LTE backhaul, in that case T-Mobile, and then we went out beyond territorial waters, obviously beyond Galveston, off where there was no LTE coverage. In that case, we brought the core with us. An important learning experience because we were providing voice between a Coast Guard vessel and our vessel we were allegedly chasing as a bad guy. Let's see, and in the bottom right, one which I'm sure many of you suffered our stories of, my apologies, we covered the Super Bowl last year in San Francisco, and there we put up a two-node system. So this is the foundation on which we built much of our offering. Do you ever hear stories of how some obscure third world country is adopting some new telecommunications technology that's making it leap far beyond the United States? Makes your blood boil for a minute, and usually when you actually read into it, you find it's not quite true. The example of FirstNet is one of those domestic cases. So going from LMR to LTE with either VoLTE or push-to-talk, mission-critical push-to-talk, we are leaping over the existing cellular infrastructure. FirstNet is not about 2G, it's not about 3G, it's about leaping into the future where we're all going to be in terms of our own cell phones. There are a lot of pieces of technology that need to get stable before they're FirstNet ready, before they're mission critical. One of them is push-to-talk, which I'll talk about in a minute. The other one is security issues, direct mode. There's a lot of pieces we've got to figure out before this network can replace LMR. And I just want to provide you a vision. Last Monday I was at MITRE, which is a research shop outside DC, and there was 150 of us in a meeting about 5G and security issues. And so in each one of these missing areas, in direct mode, in security, in push-to-talk, there are teams of people working on standards and teams of engineers working on developing product. And the goal is obviously, so the next year or so, to bring the product up to a standard where it's close to LMR, maybe beyond LMR, and then have adoption over the next few years. This is a process, it's a long process. I also want to give credit to Andy Thiessen at PSCR, the work that he's done in terms of taking public safety standards and migrating them into the 3GPP process, something Mel contributed to a number of years ago. Has been real important. Getting these standards to move from public safety into the mainstream is the only way to make handsets and other devices economical. So, onto the topic that Ken has asked. Public safety is migrating from land mobile radio, which we've talked about today, to 4G LTE, the Fairfax County being a great example of one of those exercises that helps us learn what works. And LTE is an all IP end-to-end connection. I think many of you may know that, just like the IP that is used in your home to your home router and your home internet service. IMS deployments, this is a complicated area and limited so far. It's obviously not the mainstream even in terms of your consumer cellular devices. And I remember going back to 1999, so these things take a while to migrate into the market. Excuse me, my colleague is pointing out that I failed to advance the slide. Thank you. So we got two voice options for public safety. We have mission critical push to talk, which we'll be demonstrating in the booth, and also VoLTE. So two different options to move voice around. The goal is service continuity, which means as I go from a vehicle into a building, I need to have the communication be uninterrupted. As I move from urban out towards rural, I need to have the communication be uninterrupted. If we're going to move from, let's say, VoLTE to voice over Wi-Fi in the building, if that's the way we're going to go, we need to have that be uninterrupted. And by the way, I'll echo something Ed Mills from Colorado said the other day. He said, whenever I'm a firefighter and I go into a building, the first thing we do is turn off the power. Something which we in communications may not think about. So the first thing the firefighters do when they walk into a building is they pull the power. Think about that as we're deploying in building systems. So also call quality and resilience is obviously critical, especially because unlike analog, unlike LMR, there's not a lot of gray area in digital communication. It's mostly binary. It's on or it's off. So there will be no forklift change from LMR to LTE. Nobody's going to come in one day and say, okay, you've been using LTE in a test environment for the last month or the last 6 months. Your officers are going to come in this morning, and the officers are going to be issued new equipment, and the old one goes off. There will be no forklift. The migration, the technology needs to support a migration that'll be at whatever pace each individual law enforcement officer or firefighter, EMS, or each agency is ready to do. It needs to be at their pace. And for that, we need some technologies that allow LMR and LTE to interop simultaneously. So that, as I said, you can move one radio over at a time or one agency over at a time. It has to be at the pace at which the users want to adopt it. We built a piece of technology called the HeadNet Gateway, which does a lot of things. One of the pieces is it's integrating the push-to-talk option with LMR with the LTE. So you've got to be able to have transparency across. You may also know MutualLink. MutualLink is a firm that has done a great job making this capable. eChat, I think, is represented here in the audience. So there are a number of firms that have solutions that allow for migration from legacy to current. So in this architecture, we're talking about transitions from, in one case, in vehicle, moving into in building, and with a HeadNet gateway, which most people think of HeadNet gateway as providing some sort of SON functionality around the fixed network. So you put up a new eNode in a tower, and the self-organizing network capabilities designed to identify that one fixed location and integrate it into architecture. LTE, you probably know, was designed to be a fixed infrastructure. LTE wasn't designed to move. The subscribers move, but the eNode Bs are supposed to stand still. In the architecture that public safety is going to adopt, it's not going to be the same as the legacy LTE architecture, either from today's vendors or today's carriers, because we simply can't afford it. Let me just give you two metrics. There are, say, 3 million public safety people in the United States. 12 of them stretch it out to second responders. The break-even number for public safety, the break-even number for LTE network is about 40 million users. So we've got this big gap between the number of possible subscribers in public safety and whatever the break-even is. How do we bridge that gap? Part of it is by driving down the cost of the hardware and the software, but the other one that's equally important is changing the architecture. And so having an architecture that allows for mobility of eNode Bs, that allows one to put eNode Bs and base stations in vehicles and have them move around, either to extend coverage into rural areas or to provide in-building coverage as the vehicle approaches is important. And so the SON technology, which many of you may be familiar with around fixed infrastructure, is now going to apply to the mobile infrastructure. So when vehicles move, the SON will enable more easy handoff between the vehicle and an officer as they run into a building. So this is an example of the sun around mobility. So there you can see the police vehicle, and the police vehicle has in it, let's say, a 1 watt E-node B, and it's broadcasting a band 14 bubble around the police vehicle. It needs to be able to stand alone and have a core, some sort of EPC embedded in it, because there will be times when it's off the network and can't provide communication. And then whatever the voice application is going to have to live on the server with the vehicle. So one of the first parts of the design here is imagine it being isolated from the core EPC, and the vehicle has to be able to operate where there is no connectivity back to the network. Almost every police jurisdiction, whether it's urban or rural, has some places where this is important. It needs to be able to operate off the net. So in this case, the voice apps will be able to reside in the moving vehicle. And the vehicle will have one of our COWS, the CWS 210, such as it was deployed for the Rose Bowl in the staging area back in January. And in that case, it's a little vehicle, a little device. It's maybe 8 inches by 8 inches square and maybe 6 inches high. That has both the E-node B and the core. And the voice applications in this case were mounted in a Mint box, which had the core as well attached to the CWS 210. While the vehicle is in motion, we anticipate that a handset, like a Sonim handset, will use Wi-Fi to connect in to the device that's in the vehicle. And then when the vehicle stops, it will flip, and it will use LTE for its communication between the handset and the radio. In this case, the HeadNet gateway is the piece of intelligence that connects all of this, that knows where the vehicle is, whether it's moving, whether it's standing still, whether handsets can be served through the fixed environment, the fixed tower environment, or whether it needs to be served by the moving vehicle. And as has been said before, LTE does not like moving nodes. That wasn't part of the plan. The idea was that the towers were going to stand still. You know, I heard a great term yesterday. There was a flying E-node B. I think that was one of Mr. Schleckaway's from NATE's talk about how to use drones around towers. So in this case, the vehicle is approaching an incident. It stops. At that point, the in-vehicle unit gets switched over to LTE and is broadcasting LTE, providing that last connectivity to the handset. And that's LTE on phones, any device that's in the vehicle, such as a laptop or license plate reader, that'll continue to be connected by Wi-Fi. And the goal is to provide continuity so that even as the vehicle stops and it makes a shift as what that last, what's called the last mile communication is, the HeadNet gateway maintains the connectivity. In this case, we've got the example on the left where we're showing the attempt to hand off between the in-building cell on the bottom left there to another tower, and an officer, a law enforcement person, moving back and forth between one and the other. Right now, the intelligence network is as likely to drop that communication as it is to maintain connectivity. Now, there's certainly a lot of applications, like most data applications, you could drop it as you're transitioning from building to outbuilding. However, if you have voice needs a different kind of network intelligence to provide continuity. Voice is the least tolerant of the various media. And this is an example of what we're very fortunate to be invited by LA Ricks to do, where we had the mobile 210 that can sit in the vehicle, and it can move in and out of data, can move in and out of tower coverage, and it's providing connectivity because the HeadNet gateway is looking to see where it is. This is an example, and I'm going to go back for a moment to GIFX. GIFX is the exercise I mentioned in California. It's a joint interforces which has public safety as well as military. And in that case, the example that we, and I think other vendors were striving to do, was to have a series of E-node Bs that were connected at each end, one to satellite and one to land, one to terrestrial communications. And taking advantage in that case, I think we used the Houston County, the Houston County Corps. Houston Harris County Corps. In that case, we want to demonstrate that we could take advantage of the voice capabilities that were in the core, and we unplugged the satellite to demonstrate that this daisy-chained set of E-node Bs would communicate by mesh and take advantage of the voice app that was resident in Houston. And then we plugged the satellite back in again and disconnected the terrestrial connection, again to prove that it was connecting back to the EPC in Houston. So in that case, we're trying to demonstrate resilience, and the resilience happened because adjacent to the Erickson EPC that's in LA and the one in Harris County is our head-net gateway, and that's what's watching to see which ENODs are on, which are off, what's the signal strength, is the footprint overlapping. Obviously, that's critical for the devices taking advantage of the networked applications like voice. So I invite everybody to come and see a demonstration. We have handsets that you can touch and feel and see how they work. Come by our booth at 1572, and we'd love to show you how some of this is working as a result of exercises that a good number of you have made possible. So thank you.